Hi everyone, this is Ashwin here. In this video, we are going to see about data augmentation for text. Usually you would have seen data augmentation for image, but it is very rare to see data augmentation for text because majority of the people were not using that. So what are the uses of data augmentation in general? The first use is we can increase the dataset size by creating more samples. And the second one is we can reduce overfitting. I'll just say reduce overfitting because that is a common problem we are facing for in all the model training. Third one is we can improve model generalization. And the last one is handling imbalanced data set. So whenever there is a imbalanced data, you can create additional samples for the minority class. So using this method, we can achieve a lot of things. So for this, we have to install a module. Let's say pip install NLP augmentation. I already installed this module. After installation for one specific module, it would ask for additional installation for another module. So I'll just add that here as well. So just install these two modules. If you just run it, it will install the module for you. So the notebook will be in my GitHub repository. Feel free to use that. Now let's import the module. Import NLP augmenter dot word as NAW. As this is a long import, I'm just using alias. So this is just a warning. If you just run this again, it will go away. The module is still importing. Let's leave it some seconds. In the meantime, we will go with the first method. The first one is synonym replacement. Synonym replacement. What it does is it will just replace words with their synonym words. So when you replace the word with their synonyms, we won't lose their meaning. We will actually retain the meaning, but syntactically we will generate new samples out of it. So for this, I'll just create a common text for this. Let's create it here. Text equals the quick brown fox jumps over a lazy dog. So this is the text I'm going to use. Now we will initialize the augmenter. So I will call synonym augmenter equals NAW dot synonym. If you just press tab, it will autocomplete. And synonym augmenter. And there are two modules we can use. You already would have seen WordNet. We will be using that. Org source equals WordNet. You can also check NLP org documentation for using other modules. Now synonym text equals synog dot augment of text. Let's print it. I'll just say synonym text and print the synonym text. Okay, this is augment source. Run this. See, now it is working. So this is our original text which we've passed, and this is the resulted output from the augmenter. Quick is replaced with immediate. Brown fox jump out over a work shy dog. You can also run this again. Now you can see the warm John brown fox jump over a lazy dog. So all these things are like synonym of the original text. Some of them make sense, but some of them I'm not sure why the John is appearing for quick. Maybe it can be a synonym, but we have to check that. Let's try a few more times. So look for this example. Again, I just replace the synonyms for this. Lazy is there, and the dog is replaced with Andiron. So like this, for whatever text you are giving, it will just replace it with synonyms randomly. So you can keep on generating like multiple times for getting more semantically meaningful output from this, and get more samples using this synonym replacement. Let's try out the next one. The next one is random substitution. Okay, now I'll just initialize subaug equals naw dot random word augmentation action equals substitute. Now we can just do the same thing. Substituted text equals subaug dot augment of the original text. Now we can just print it. With the substituted text we got. Let's run this. Now you can see some of the words are just replaced with underscore. So this is like random substitution. So I think you would have already known about dropout or regularization. So we will intentionally drop some nodes while training a neural network. Similarly, we are just dropping some words in the original input text to make the model more generalized. So this is one more method that you can use. So like this random word augmentation, we can have like additional action like random deletion or random swap. We can try both of them now. So I'll just quickly create both of them. Random deletion. I'll just copy this for quick replacement. Here we are going to do delete and deletion text. This will be deletion text. Run this. Now you can see it retains the meaning, but it just deleted a few words. The is missing, fox is missing. Like that, it just deletes some words, but it doesn't delete most of the words, because if we delete too much means we might miss out the meaning. Let's also do a random swap. Again, I'll just copy and paste it. Swap aug. The action will be swap. This will be swap text. Swap text. Now you can see the quick brown jumps fox a lazy over dog. It just swaps adjacent words, and because of these things, the model will generalize more, and we have to adjust the probability, like how much you want to augment the text data. You can find more parameters in the NLP documentation. So these are some of the basic augmentation that you can do. So the last one will be back translation. So all these things is just individually replacing the words and producing our result. So this is just word augmentation. So far we are using only word augmenter. In the same word augmenter, we can use a semantic model. So what it does is it will translate original text to other language like German, and convert back to English language. So while doing this conversion, we may not get the exact same words out of it, but it will retain most of the meaning. So let's try it and see what it gives. Back trans aug equals NAW dot back translation dot back translation augmenter. So here you can specify some model parameters. So by default it will convert the English language to German and German to English. If you want to use some other model or some other language, means you can pass it in the parameter. There will be like from model and to model, like that you can pass it. For this demo I'll just leave it as it is and use the default parameters. Let's generate the text. Back trans text equals back trans aug dot augment of text. Let's print it. Back translated text, back trans text. Let's run this. So if you are running it for the first time, means it will download both of these modules, like model weights and vocabulary, everything. So it will just take some time for you, but after initializing the model it won't take that much time. So let's wait for a while. It just loads the model weights, and it has to convert the English language to German and German to English language. Okay, we got our results. As you can see, it is using Facebook model, and it is converting English to German and German to English. And this is our result. The speedy brown fox jumps over a lazy dog. It just replaced the quick with speed. This is just for a sample example text. So if you are doing it for other sentences, means it could replace other words into a more meaningful words. You can use all of these modules with some probability measure, like 20% of the time you can do some augmentation and train the model, like we have done it for image data. Let's just rerun this again, because it just generated additional warnings. It will just generate the same text again. So all these data augmentation we have done so far is based on word augmentation. Like this, there are sentence augmentation as well. You can also explore that and change the whole meaning. So that's pretty much it, guys. You can use all these things and specify some probability and randomly swap or delete or substitute some of the data. But overall, I would say a synonym replacement and the back translation would make much more sense. This also makes much more sense if you are having a lot of data and the model is going for overfitting. So just use it accordingly for your use case. And that's it, guys. Thanks for watching this video. Catch you guys soon.